Hello students, this is Design of Machine Elements 1, Chapter 2, Static Failure Theories. This is tutorial number 2. In this example, we have given a round bar made from AISI 1018 hot-rolled steel, and this bar is subjected to principal stress of sigma A equal to negative 80 megapascal and sigma B equal to negative 100 megapascal. So these negative signs indicate the stress on the surface of the bar are all compressive. So given this data, we are required to find out the factor of safety of the round bar using maximum shear stress theory and distortion energy theory. As always, we start from extracting the given information. Material is already selected. It is AISI 1018 hot rolled steel. And these stress are given, and the stress, don't forget, the stress are principal stresses. So in the previous example, the given stresses were induced stresses or working stresses. But in this case here, we have given principal stresses. Principal stresses are stresses which are either maximum or minimum that occur on the surface of the bar. So given this data, we are required to find out factor of safety using maximum shear stress theory and distortion energy theory. So going to the analysis part, so this is a load diagram of the round bar. So on the surface of the round bar, if we consider a point, then we can draw the plane stress state where we have minimum and maximum principal stresses. So sigma A compressive, sigma B compressive, as shown with the arrows into the element. So now let's find out the factor of safety using maximum shear stress theory. So again, from our previous lecture, we know that maximum shear stress theory is expressed either in terms of principal stress like this, or it's expressed in terms of applied stress or induced stress like this. So on this problem, we have given principal stresses. So sigma A equal to negative 80 megapascal and sigma B equal to negative 100 megapascal, which are all compressive. So because the given stresses are principal stresses, then equation 1, this equation will be applicable for or suitable for solving this problem. So you always need to put these principal stresses in their increasing order, like sigma 1 greater than sigma 2 greater than sigma 3. These all three stresses are principal stresses. So this is for a three-dimensional stress state where we have a cube element. So this is a triaxial stress element. We say this is a triaxial stress element. So that means we do have one stress sigma 1 this way, sigma 2, we do have it this way, and sigma 3 acting on the other plane. So we do have three principal stresses. So you need always to put this stress in this ascending order or increasing order. Now, you need to identify the maximum principal stress and the minimum principal stress. So putting things in this order, sigma 1, which is because the rest stresses or the rest principal stress are negative, while the maximum stress, the maximum principal stress by default is going to be 0 megapascal, and sigma 2 is negative 80 megapascal, and sigma 3 is negative 100 megapascal, meaning all stress are put in this order, in their ascending order, meaning sigma 1 is greater than sigma 2, sigma 2 is greater than sigma 3. Now, once we put this thing, once we have identified the maximum and the minimum principal stress, then we can use this equation 1 to find out the factor of safety. Notice that here the only unknown thing in equation 1 is Sy, but again Sy is given in a different indirectly because already material is specified. So using this ASI code 1018, we can read mechanical property table, and then we can find out Sy to be 220 megapascal and the ultimate stress to be 400 megapascal. Now you see that every value in this equation is known except the factor of safety, which is n. So sigma 1 is 0, substitute 0 here, and sigma 3 means it's the minimum principal stress, which is equal to negative 100 megapascal. If you substitute these values, then you get, if you substitute the values and you calculate for n value, then n is equal to 2.2. This is factor of safety of the round bar using MSS theory. Let us apply now the distortion energy theory for the same bar, which is subjected to compressive principal stresses, 80 and 100 megapascal. So distortion energy theory again is expressed as it can be expressed in the principal with the principal stresses, or it can be expressed with induced stresses. So here it's clear that again equation 1 is applicable for this case because the given stresses are all principal. So we apply now in this case equation 1. So as usual, always you need to order your stresses in their ascending order or increasing order like this: sigma 1 greater than sigma 2 greater than sigma 3 for a three-dimensional stress state. Definitely one for plane stress, one of the two is going to be 0. So you do have your sigma 2 value and sigma 3 value like this. But sigma 1 is automatically 0 because it's a plane stress. It is a two-dimensional stress state. So putting things in order like before, we have sigma 1 to be 0, then sigma 2 negative 80, sigma 3 negative 100 megapascal. So the maximum principal stress is 0 and the minimum principal stress negative 100 megapascal. So direct substitution of these values into equation 2 here in this equation, if you substitute it in this equation, you already know what Sy value is, which is 220, the thing that you get from table. So the only unknown thing here will be n value, which is safety factor. So you can calculate the safety factor after plugging in all values here on the equation. Then you get n to be 2.4. So this is the safety factor that we calculated using the distortion energy value. Here, you need to notice again the thing that we have stated earlier in the previous tutorial. Always factor of safety that we get using MSS theory, are less than from the factor of safety that we calculate using the TE theory. That's why always we say maximum shear stress theory is restrictive or conservative. So this is how you solve this problem. So we have seen two cases. The first tutorial is when induced stress or when induced stress or working stress are given. On the second tutorial, we have seen when principal stress are given. So this is the way you solve whenever you are given such kind of problems. So don't forget always factor of safety using MSS is less than from factor of safety using TE value. Okay, thank you.